I just wired up my first custom motorcycle, and developing my own wiring diagram from scratch was the one thing that helped me to go from absolutely no knowledge and feeling completely overwhelmed to in the end being able to make a nice looking and functioning wiring harness. So I thought I'd share with you my process for developing a wiring diagram from scratch so you can actually apply it for your own motorcycle. You probably already had a look online and found that every diagram is slightly different, and that's because every bike setup is a little bit different. So the wiring diagram that you will develop is probably a little bit different to the wiring diagram that I use to wire up the BMW. And because of that, I can't tell you what you need to connect where specifically. So I try to make a general guideline that we can walk through step by step and that you can apply to develop a diagram that actually works for your bike. And the first step to that is to collect all of the components that need to be wired up on your bike. Lights, indicators, horn, ignition lock, all the ignition parts, charging system parts, everything that you can move. Put it in a box and take it to your desk, because this process will probably take a while. It took me 2 weeks to get to my finished wiring diagram. So it's good to have all of those parts and to be able to actually look at them, see where the wires come out, see which colors they have, stuff like that. But there might be some parts that you don't want to take off the bike. For example, if you have a well-working charging system or ignition system, you might want to leave those on the bike. So at this point, just try to familiarize yourself with them. See where they're located, have a look at what they look like, and then also which terminals they have, so you know where you have to connect the wire in the end. And if at this point you don't know what those parts are yet, don't worry. I also started with zero knowledge and I had to work my way through each of the components. To make it a little bit easier for you, I'm going to put a link down below with all of the parts that are on the BMW, so you can reference that. The setups are very, very similar on all of the bikes. And I'm also going to link a lot of videos down below that help me to understand what each part is, how it works, and it hopefully also helps you to better understand the whole systems and how everything goes together. So once you have all of the parts in a box, or at least know where they're located on the bike, start to go through them one by one and try to collect all of the manuals that you can find and all of the information about them. Most of the more complex parts like the Mo.Unit from Motor Gadget, or the speedometer, or the new vape ignition and charging system that I installed on the BMW, they come with very detailed descriptions and very well-written manuals. So that is great. But a lot of the simpler parts, like the headlight or the indicators, for example, often just come with a little bit of description on the website where you bought them from. So it might just say like, black is ground, white is low beam, blue is high beam for the headlight, for example. So try to gather as much information about all of the parts that you want to use as possible. And also, and this can be very, very helpful, try to get your hands on the original wiring diagram. For most bikes, you can find them online, but if you can't, then you will most definitely find it in the original repair manual for your motorcycle. Now, if you've never done this before, it might actually be helpful if we go through the individual components and talk about how they connect in general. The electrical components on your motorcycle can be separated in 2 groups, and that can make our life a lot easier because we can first focus on one group, then focus on the other group, and in the end, combine the 2 diagrams that we've sketched out, and that will give us the finished wiring diagram. But my problem in the beginning was that I didn't really know what people were talking about when they referred to these 2 groups, so I hope that I can make it a little bit more understandable for you. In the first group are all of the parts that your bike needs to run, so that is battery, ignition system, and charging system. Check out the video down below to get a lot of detail on each of the specific components, but we'll quickly go through them to just get a general understanding. On the BMW, that is the starter motor, which already has the starter solenoid attached to it. The starter solenoid is basically just a relay for the starter motor, and the starter motor is responsible to fire up your engine. Then we have the ignition coils, which connect to the spark plugs, and those generate the sparks that the engine needs to run. But that spark needs to be timed very precisely, so we need some part that actually manages the ignition timing. With the new vape ignition system, I got a part that is called Advanced or Control Unit, and that does that job. So those are all of the parts that make up your ignition system. Now we move on to the charging system, but it's still all group 1. So next up we have the alternator, and that consists of 2 parts, the stator and the rotor, and those 2 parts produce the electricity for your bike in very simple terms. But this electricity can't directly flow to your battery. We need a regulator rectifier in between for several different reasons. I've made a separate video about that, which I'm going to also link you down below. But just know that it can't flow directly to the battery, so you will need the regulator rectifier that basically manages the flow of electricity and makes it usable. So those are all of the parts that most bikes need to run, and they make up group 1. Group 2 are all of the parts that your bike doesn't really need to run, but they make your bike safer or easier to use. So headlights, indicators, horn, buttons, all of those things. So with that knowledge, we can make our life actually a lot easier, because we can first sketch a wiring diagram for group 2, which was easier for me to understand in the beginning. And then once we're done, we sketch a wiring diagram for group 1. And only once we understand the 2 groups individually, we merge them into one final wiring diagram. And all you need for that process are a few colorful pens and a few sheets of paper. And one word before we start the actual process: at this stage, don't worry about making it look nice. Like, take a few tries and just see how things connect and where things go. It can happen that your wires cross all over the place and it becomes a very big mess. Then just take your knowledge that you've learned with that sketch and transfer it cleanly to a new sketch. And that way we can improve the wiring diagram and make it cleaner and cleaner step by step. All right, let's get started. Imagine this piece of paper as your motorcycle. So we're going to focus on group 2 first. This is the front, and here's the back. Now what we want to do is to place all of the components that we have where they roughly go on the bike. So here we have the handlebars with, on the left side I have 3 switches, and on the right side I have 2. Start, high beam, turn left, turn right, and horn. Now since we're going to have wires running back, I'm just going to draw the headlight right here. On the other side we have the speedo, and then we have a left indicator and a right indicator. On the BMW, I actually used the Mo.Button inside the handlebars to clean up the wiring. But since this is a more general tutorial, I'm going to link you the video down below where I specifically installed that and also wired up all of the switches. On the BMW, I also used the M.Unit, which I quickly added here with all of the input and output terminals. Then we move to the back. We add the battery. I installed 3-in-1 indicators, 1 left, 1 right, which basically just means that this is turn right, brake, and rear light. You could also have a separate brake and rear light, so that might already be a first point where it differs. And this one in the middle is the license plate light. Now we're still missing a few things. I'm going to add the horn on this side. That has 2 terminals. And then on this side we can add the switches for the BMW. That is 1 switch for brake. We also have a front brake switch, which we can add somewhere over here. Then we also have a neutral switch and oil. And the last one for the BMW is a speed sensor. You might not have that on your bike if you are running an old school speedometer, but I upgraded to the Daytona digital speedometer, so it needs a digital signal to actually read the speed. You might also have a side stand switch right here, but the BMW doesn't have that, so we leave that. So those are all of the components from group 2. Now the next step is to go through each of them and add the wires that come out of them. So for example, in my setup for the headlight, we have a blue wire coming out of it. Then I have a white wire, but white is a little bit tricky to actually mark, so I'm using light gray. We also have a black wire, and then I had a green wire and a brown wire. So that's the process that you want to do for all of your parts. Some of the parts actually don't have wires already attached. The horn, for example, just comes with 2 bare terminals, same for most of the switches. So that's your task now, to go through each of the components individually that comes with wires and draw all of those wires in. Now the next step is to go through all of the manuals and the information that you have gathered before to label all of the wires that you have on your sketch. By the way, here's a picture of my first sketch. There might have been a few mistakes at this stage, but I just want to show you how the first sketch looks. It's not clean and there's still a lot of parts missing. Just go through it step by step and try to not lose your mind. And speaking about not losing your mind, as you can see here, I had the luxury of using the M.Unit to wire up the BMW. That's definitely not necessary. You can most definitely wire up your bike without a device like this, but it will make your life so much easier because it eliminates most of the relays and the fuses that you would need for indicators, headlights, stuff like that. You don't really eliminate it, but it's integrated into the M.Unit, so you don't have to worry about it. If you want to use the M.Unit, I have made a video where I went through each of the individual terminals and explained exactly which wire has to go where. I'm also going to link you that down below. But in case you can't use the M.Unit or you don't want to spend that much money on an M.Unit, then let me quickly show you what a relay does, because it can be quite confusing in the beginning, but it's actually quite simple once you understand it. So the most simple circuit looks like this. We have the battery, and then a part, let's say the headlight, which is also called load often, and that is connected with a positive wire, and then the other side is connected with what is called ground wire. So without a switch, that would already be lit up. Now, if we add a switch, we have the battery, then the positive wire, let's add the switch right here. That is the symbol for switch. Now, once you press the button, this closes, right? And then current can flow that way. That is the symbol for closed switch, and only then the bulb will light up. The problem that you might run into with a circuit like this is if you have a very powerful device, let's say like the high beam bulb, for example, all of that current needs to flow through the switch directly. And a lot of switches have very tiny terminals and they don't really like that. They can't handle that much power. So in order to not send all of that power directly through the switch, we have a relay. Let me quickly show you what that looks like, because it's actually quite simple once you understand what it does. Again, we have the switch, but on this side, it connects to this little black cube. It's often just a black cube. And that black cube has two more terminals, one right here and one right here. And there we have a bigger wire that also connects to the positive terminal. And on the other side, that continues to your light bulb. And then from here, we again have the ground wire going to the negative terminal on the battery. So what the relay does is basically in here, we have something that also acts like a switch. And then here we have something that looks like this, but it doesn't really matter. As soon as you press the button and this closes, that activates and closes this connection right here. So current can flow through, but it doesn't have to go through the switch. It goes directly from the battery to the light bulb, and that turns on. That is all a relay does. So hopefully that makes it a little bit less intimidating if you have to work with those. And for fuses, I think a general rule of thumb is that you want to have them as close to the positive terminal of the battery as possible, so everything that comes after is protected. Now the next step with our sketch is to connect as many wires as possible. And since I started with absolutely zero knowledge and I had so many basic questions, I tried to put together a few general things that hopefully help you to make sense of this. The most basic concept is that every part needs a positive and a negative connection. As you've just seen in the basic circuit, we have the battery, positive, negative, positive lead, then the load device, and then the round wire. But sometimes that can be a little bit hard to understand when you look at the part. For example, the 3-in-1 indicators that are used on the BMW, they have 4 wires. 3 are positive and only 1 is ground. So we have 1 black wire, then we have a red wire, a blue wire, and a yellow wire. And how that works is that the ground wires are already connected inside the housing, so it might look something like this. So they all connect into one, and then just 1 wire leaves the housing. That obviously cleans up the wiring, but in the beginning, if you're new to this, it sometimes might be a little bit hard to understand why you just have 1 ground wire and how everything goes together. But we'll talk a little bit more about joining wires in just a second. Let's first cover the basics. The positive side of your part is somehow connected to the positive terminal of your battery. If you use the M-Unit, that connection goes like this. From the positive terminal of your battery goes a wire to the battery terminal of your M-Unit, and in between there is a fuse that protects everything that comes after that. So this connection gives power to the M-Unit, and from here the M-Unit distributes that power, so the power goes out from the output side. So we have to look, where's the horn terminal? We have the horn right here, and now it gets a little bit messy. We just go like this, up, across, and then on the horn you have a terminal that states 12 volt. Now we still need the second part of the circuit, which is the ground connection that goes back to the negative terminal of your battery. And for that you have different options, but they all do the same thing. Everything leads back to the negative terminal of your battery. You could either use a wire that runs directly from the horn to the negative terminal on your battery, but then if you did that with all of the parts, you would have like 10 or 20 wires running to that one terminal, which will probably make it quite messy. So what you want to do is to have one big wire that runs from the negative terminal of your battery to the engine. On the BMW, it connects with a ring terminal to a screw in the back. So let's draw this in, and let's just put a little box right here and name that engine. And you have one big wire that goes there. So now, since most of the parts on your bike are made from metal and are connected with metal screws, the whole bike basically becomes one big ground wire. So you can run your ground wire to any point that has a good connection, and then from there it runs through the frame, through the engine, and then back to the battery. This was a concept that was a little bit hard for me in the beginning to understand how that works, but as long as you have a good ground connection, you can just hook the wire up basically anywhere. So what I've actually done in the end with the ground wire of the horn, I didn't run it back to the ground terminal of the M unit. I just made a short wire and hooked that up to the screw that I used to secure the horn to the frame. And if you want to draw that into your wiring diagram, you can actually make a symbol that looks like this. So that means you are using a frame ground. If you're doing this for the first time, it can be very hard to imagine where to use frame grounds and things like that at this point. If that is the case, just run everything to the ground terminal of the M unit and use that for your wiring diagram. Once you have finished the wiring diagram and you are on the bike, things will make a lot more sense, and you can actually see which wire does not necessarily need to run all the way back to the M unit, but where it can make a little shorter wire and just hook that up to the frame. Just one quick word of caution when it comes to frame grounds. Paint can reduce the connectivity quite a lot, and also if you use parts that are in front of the steering head bearing, so for example, let's say the lower fork tubes, which you probably won't need to use, but let's say you would use those, then the current has to travel through the steering head bearing, and then it might be a little bit tricky to get a good connection. If you want to know if you have a good frame ground in one specific spot, then just research how you can use the continuity setting on a multimeter to check for a good connection, and then you can actually specifically check the spots that you want to use. All right, now the next thing that would have helped me a lot to know in the beginning and understand is that you can join wires with the same task basically. So let's start with grounds, because grounds are always the same. You can take the ground wire from the headlight and the ground wire from the indicator, for example, and connect those two, and then as long as those make a good connection to the negative terminal of your battery, may it be through the frame, through the engine, and then through the main ground lead to the battery, those devices will work. It's a different story for positive leads. You can't connect the positive wire that goes to the headlight and the positive wire that goes to the indicator, because otherwise those two would be always on at the same time. Let's take the 3-in-1 indicators as a very good example, because here we have a few wires that have the same function and a few wires that look the same but don't have the same function. We have the same colors of wires on both sides. Red is for brake, yellow is for the turn signal, blue is for the rear lights, and then black is for ground. So let's start with the brake lights. We actually want both sides to be on when we press the brake. So both wires have the same function. That means we can connect those. And here it's actually important to color code. Choose a color that is specific for one part. So for the brake light, we're going to use purple that runs across. The wires join here. And then from here, they get power from the output brake terminal of the M unit. So like with the horn, this is our 12-volt positive connection. Now let's move on to the two rear lights, because we want those also to be on at the same time. So those wires also have the same function, which means we can connect those. I'm just going to use dark blue for that. That runs across. They meet right here. And then if you have the M unit, the rear light gets powered by aux 1. And see, this doesn't have to be super clean. You can just make the connections. It's more about understanding what goes where. Now we have the positive wires for the turn signals. And here it's very important. We don't want right and left turn signal to flash at the same time. So those don't have the same function. So we need to wire those up individually. And here you can see you run into a little problem when it comes to color coding, because both have a yellow wire. And at that point, you just need to choose which one you might continue with yellow, and then the other one needs to get a separate color. So I chose gray, I think, for turn left. So let's connect turn right first. That also gets power from the output side. So that goes here, and then this connects here. Now we only need power for turn left, and that also comes from the output side of the M unit. All of the power comes from the output side of the M unit. That runs down here, and then it connects like this. Now the last two wires that we have on the 3-in-1 indicators are the ground wires, and those also, as I've said, have the same function. So we can also connect those two. Just run this across. They connect right here. And then in my first sketch, I ran that to the ground terminal of the M-Unit. In the final assembly, I actually ran that to a frame spot. But let's just say we run this to the ground terminal. And drawing wires that run across like this definitely doesn't make it look clean, but it helps you to get an understanding of what you have to hook up where. And to not get things confused, what you want to do is wherever wires actually join and not just cross over each other, you want to make a dot. So that's the sign for a connection. Now, while we speak about joining wires, it can also be helpful to understand what splicing into a wire means. Let's say you have a wire that runs from point A to point B, but you want this signal also to run to point C, right? Then you would take another wire and splice that in here. If you want to know how that works, you can check out the video where I actually wired up the BMW. I had to do that a few times, but you can also Google tutorials on how to splice into a wire. What that's useful for is, for example, for your high beam actual light and the control light in your speedometer. Let me show you in our sketch. So here we have the positive wire for your high beam bulb, and that goes to the output side high beam of the M-Unit. So that gets power from there. But we also need the control light on the speedometer to light up when the high beam is active. So when power flows through this wire to the headlight, the power also has to flow through the blue wire in the speedometer. So you can either splice in here and get that power to the speedometer this way, or what I've done is I've just added 2 wires to the same crimp connector in the high beam output terminal. So my setup would look something like this. But that's just 2 options of how you can do it. Now, the last thing that I quickly want to show you that hopefully helps you to wire up your Group 2 is how you wire up switches and buttons. They all have the same design and it's super simple. They all have 2 terminals and you still need to connect one side to the positive and the other one becomes ground. But it doesn't matter which side you choose, because let me show you what that actually looks like. So let's say we have the same switch. This is terminal 1, this is terminal 2. In our drawing, that is terminal 1 and that is terminal 2. So let's say we first choose the right terminal to be positive and the left terminal to be ground. And in the second one, we choose the left terminal to be positive and the right terminal to be ground. All the switch does is make a connection between here and there. And it doesn't matter if that is this way or if that is this way, basically. That is a very, very simple explanation and probably technically not 100% accurate, but I hope it gets the point across, because that is all you have to know in order to be able to wire up all of your buttons and your switches. So let's do the button for turn left as an example. I draw in 2 terminals right here. I hope you can see that. One will be the positive wire, and all of the buttons and switches connect to the input side. That basically gives the signal, okay, we need to activate the output terminal, and that then gives power to the corresponding device. So let's go from one terminal to the turn left input right here. And then the other side, we just take that wire and run it to ground. And that's already your switch wired up. That is how you wire up all of the other switches as well. Let's do the high beam as the next one. High beam, just need to see where the high beam is. High beam connects to light on the M-Unit. So that runs down here into there. And then we have the ground, and that can actually, as I've said, connect to another ground. So we connect those and then it runs back in just one wire to the ground terminal of the M-Unit. Before we do a speed run through all of the other connections, I noticed that I'm missing one thing, and that is the ignition lock. The ignition lock that I use on the BMW has 3 terminals. One is ground and the other ones are basically, let's say, P1 and P2. Those are the positives for the 2 different key positions, and I only need on or off on the BMW. I don't need the 2 key positions, so I made those into one by connecting those 2 wires. And that wire runs to the positive terminal of your M-Unit. So that connects right here. And the other wire, the ground wire, goes to the lock input side. That activates the M-Unit once you turn the key. Let's quickly run through a few of the other things on here. For the headlight, we need power to the low beam. That comes from the light output. So we come from here, up, and then here. Since I don't need the pilot light, what I did was to connect the wire that gives power to the pilot light to the low beam power wire, basically. And then I also connected the 2 ground wires So I connected those inside the headlight bucket, and then I ran that back to the frame actually, but in this case I'm just going to draw it in as a ground to the M unit. Now let's also wire up one indicator. It's the same for both sides. The ground goes to the ground terminal, and then for the right one I chose yellow, so I actually used the same color of wire, and I've just plugged 2 wires into the same terminal right here, so that comes from the same terminal and gives power to also the front right indicator. Left indicator wires up exactly the same way. The positive goes to the turn left output and the ground goes to the ground terminal. The front brake switch, let's quickly do that as an example. It's the same for the rear brake switch. We also have one terminal that goes to the input side. So that is brake right here. So we take that, run that up. It's very messy, as I've said at this point. Boom. And then the ground can come down and go either into this wire or directly to the ground or a frame ground. I actually made a frame ground, so we're gonna make a frame ground symbol right there. Now let's quickly talk about the speedometer, because we have a few things going on here. We have a lot of wires coming out of there. The purple one is oil, then the brown one is neutral, blue one is high beam, the yellow one is turn right. The white one is for the speed sensor, the black one is ground, red 12 volt positive, and then these 2 wires on the side are for like menu and selection and stuff like that. I did not use those because the Speedo actually has 2 buttons on the back that have the same functions like these wires. But let's quickly go through them, how we would wire those up. For oil, that runs down here and connects to one terminal on the oil pressure switch, and then this one is actually inside the engine housing, so it already is grounded there. So we don't need a separate ground wire. The neutral switch, that is brown, so we can actually use the same color. Same thing, that goes to one terminal right here. And the neutral switch does have 2 terminals, so we need to have another wire coming out, but I also grounded that on the engine, so that goes like this. And then the brake switch for the rear is the same like for the front. We also have one terminal that needs to connect to the input side of the M unit or to the wire that comes from the front brake switch. That doesn't really matter. I added 2 wires to the same terminal, so we have one wire. Now it's getting very, very messy. That runs there. And I also made a frame ground connection, but you could also run that to this ground terminal right here. Now we still need to wire up the speedometer, and for that I actually connected the 2 grounds like so, and then spliced in a wire that would run to the ground terminal on the M unit. So that gives me ground for the sensor and the speedometer. And I did the same with a 12 volt positive wire that gives power to both devices. So the other basically just give a signal to light up a light or not light up a light, and this gives general power to these 2 devices, and that comes from AUX 2. So I splice that in right here. And then the last wire that we have, that is white coming out of the speedo and yellow coming out of the speed sensor that transmits your speed. We just have to connect that. All right, I hope you can still follow with all of the wires going on. The last thing that we need to wire up for group 2 is the license plate light. And here you can either run that to the AUX output on the M unit, that gives it power whenever the M unit is turned on. But what I wanted to do to reduce the wiring in the back, I actually thought, okay, the license plate lights should always be on when the rear light is on. So I can join that into those wires as well. So whenever the rear light is on, the license plate light also turns on. And then we only need the ground connection. And as I've said, grounds are always the same. So you can join that into any ground lead or right to the frame. Now you have a very, very messy first sketch of your group 2 wiring diagram. But it doesn't matter that it's so messy, because now you can go ahead and clean this up. Just take a fresh sheet of paper, draw in the individual components again, and then use a ruler to only make vertical and horizontal connections, and that will already clean up a lot. And once you're done with that, the next step is to deal with the group 1 wiring diagram, and that is for your ignition and your charging system. I fortunately received all of those parts in a box because I upgraded to the vape ignition and charging system on the BMW. So I actually had all of those parts and could look at them and see where the connections are, which wires come out of which part. If you don't have that, as I've said, familiarize yourself with the parts on the bike and check the original wiring diagram. That helps a lot. Just trace the wires and see how they connect. It can be a little bit confusing, but if you're able to extract only the necessary connections from the original wiring diagram and copy those to a clean sheet of paper, that already makes it so much easier. That's also how I learned to understand the wiring of the vape ignition and charging system. I just took the wiring diagram they provided and copied that on a clean sheet of paper, added the right colors to the wires, and that already helped me to get a better understanding of how everything worked. In the end, I still had a few wires that I didn't know where to hook up to, and if you have the same, don't shy away from sending an email to the manufacturer. I sent an email to Motor Gadget and an email to Vape to clarify a few things that I couldn't find answers to online, and they helped me out a lot. So don't shy away from actually contacting the manufacturer, because sometimes they are the only ones that can give you a definitive answer. Now, once you have the two individual wiring diagrams, it's time to merge those together, and they're often just very few connection points. If you have the M-Unit, that is the connection point. If you don't have the M-Unit, you need to figure out where things connect for your setup specifically, but that shouldn't be a big problem once you are at the point where you understand the two groups in themselves. Maybe get a bigger sheet of paper, draw a new layout of your parts where you connect all of the parts in one layout, and then in the end you hopefully have one big wiring diagram for all of the parts that need to be wired up on your bike. The next steps will be to calculate the right wire sizes, the right plug sizes, and also think about the right plug locations so that everything is still serviceable. But we'll talk about that in the next video. If you want to grab the updated version of the BMW wiring diagram, I'm also going to link that down below. You can use that as a great reference, but keep in mind that every setup is a little bit different. I hope this video helps you to develop your own wiring diagram that works for your bike. If you have questions, feel free to leave them down below in the comments. Once the next part is out, you're going to find it right there. As always, thank you very much for watching, and I see you in the next one.